All right, so welcome everyone. Today we're going to speak about different ways to deal with asynchronous code in JavaScript. This is going to be the first out of two meetings, so it's not possible to, let's say, squeeze everything into half an hour. So whatever we cannot finish by this meeting will be just postponed to the second meeting that will take place in 2 months in December. So my name is Tomasz Ducin. I'm working as software architect and developer. I'm mostly interested in designing large-scale enterprise interfaces and coding them, obviously. Apart from my daily work, I do trainings on JavaScript, TypeScript, frameworks, and last but not least, asynchronous code. So let's begin. What we're going to start with is basically functions in JavaScript, which is, I would say, the most fundamental part of the language. We'll talk about synchronous and asynchronous invocation. Then we'll discuss the event loop and run to completion. So these are the most important mechanics of low-level JavaScript execution model. The first approach we can use is basically callbacks, right? So timeout events, this kind of stuff. Then we'll discuss promises. A promise is a representation of a single operation that is going to be executed in the future, right? But we know what to deal with it afterwards, upfront. Before it's completed, we know what to do with it later. So a promise is something that was added into the ES6 standard along with generators. When we combine promises and generators and add a tiny wrapper, we get a coroutine. A coroutine is a representation of a story. So it's going to be a sequence of multiple operations that form a bigger thing that we can basically use either in Node.js backend processing, bless you, or front-end interfaces when we have multiple steps that form a bigger story, such as doing a bank transfer. We have to input some money, then we go to another page that we need to confirm what we have, then we need to validate the token, and finally we get the confirmation. So when we have multiple coroutines talking to each other within the single thread of JavaScript, we get a pattern that is called communicating sequential processes. That's basically multiple coroutines blocking and unblocking each other. If we get coroutines and basically get them built into JavaScript, as is, we get async await. These two concepts are basically the same. This is just, let's say, premature, and this is mature, right? This was just, the wrapper has been built into the language. So this, let's say, part of the graph is when we have different kind of operations, right? A promise is a single operation. These two are a sequence of different operations. So what if we have a multiple operation? The same kind of operation that basically happens multiple times, one after another. We get events, right? It's way enough to use events if we have, let's say, shallow logic. So if an event happens, then we can handle it with a single function. But what if an event would have to trigger another event, that another event is going to filter or map or do something, let's say, more sophisticated than just invoke a function with it, right? Then we can use reactive streams to form a bigger, let's say, more complicated logic that would be very, very difficult to deal with if we just fell into callback hell with straight events. So basically, this is the content of the two talks, and I guess we're going to pretty much cover this part today. So the motivation for this talk is basically that whenever I join a developer team or I do a training, I find out that many developers are trying to, let's say, do some kind of brute force to make JavaScript work even without understanding what is going on beneath. And also that we used to have just callbacks and promises, but now we have also coroutines, async await, and reactive streams. And it's beginning to be more and more complicated just to pick up the right tool for the right job, right? So this also to make it clear when to use what, to pick up the right tool for the right class of a problem. So the first thing to realize is, what does synchronous and asynchronous actually mean? So synchronous is something that is blocking. And this means that if I have something that is pretty much available, I get it straight away, right? So if I want to access a value of a variable, I just have it now. But if I want to ask to get some water, for example, this is a resource that will come in time, right? So I have to wait for it. And now, if something is synchronous, is blocking, I'm just going to wait and do nothing until I get it, until I can proceed to the next line in code. And in non-blocking, I'm going to move it away, do something else, and then I would like to come back to the task. But the thing is, I cannot come back to the task because I am the thread that is executing the task. So somebody else have to give it to me, right? And this is where event loop kicks in. So basically, when we write code, it's always linear, but the execution of the code is not necessarily linear, right? So when you come from, let's say, I know, Java, PHP, .NET, or any kind of different, let's say, community or different platform, you can find it pretty much, let's say, strange that the code is not executed linearly, right? That in JavaScript we have this part, and then this part, and then this part, this part, this part, this part, right? So this is what is pretty much special about the platform. So if I wanted to be synchronous, and if I wanted to make myself tea, I would set up the water in the kettle, right? Then I would wait for the kettle, basically doing nothing. This might take a minute or two, right? Then, only then, after the water is ready, then I would pick up a tea bag and then I would just pour in the water. And if I'm, and this is what we don't do, right? So when I am working in an asynchronous manner, then I'm setting up the water and I have to wait for it, so I just put it away, right? Then I get the tea bag, I put it in the mug. Now that's the moment that I just don't have anything to do, right? So now I'm idle. And then I will just be reminded that this thing is just waiting to be used further. So in terms of humans, I would just remember that. But in terms of concurrency in general, there has to be some mechanism that will notify me, now do this, and now do this, because the task is ready. All right, so we have generally, we have two types of concurrency. The cooperative one, where all the threads are equal, and the preemptive one, where there are more important tasks to be done and less important tasks to be done. So the preemptive one is just like operating system. There might be a task running, and then the operating system will say, oh, that one is more important, so it will just kick out the less important one, right? And the more important one will basically come in. With the cooperative one, everybody is equal. Everybody is just the same, right? Like in communism. So when you enter a queue, right, there is no way to, let's say, gently get at the front of the line, right? Because you have to wait. If there is a message that has been put into the message queue, there is basically no place to be executed immediately, right? You have to wait until the previous messages get executed. This explains why setInterval and setTimeout functions, I guess we all know these functions, right? They don't guarantee the exact time, right? They guarantee what? The minimal, at least. They guarantee the at least, right? This is because if there are some tasks running right now, then there is no way to preempt, right? We cannot kick out the tasks. Moreover, if there is somebody before us, this task has to be done before us, right? So the most important thing for us to realize is which callbacks are executed in a synchronous manner and which are executed in asynchronous manner. The easiest example for synchronous is, let's say, array, for each, map, filter, find, reduce, and all these kind of functions. And for asynchronous, it's setTimeout. Basically, when we run the code here, synchronous invocation means it's going to be executed straight away, and after it's finished, it will carry on with the rest of the code. Whereas in asynchronous call, it's going to go here, it's going to register the call to be done later. This is the synchronous part. It's going to skip the function. It's going to carry on with this part until it's finished. And then the message would eventually get to the message queue. Just a question, do you know what is the invocation of promise constructor? Synchronous or asynchronous? Please speak out louder. Sync, yeah, that's sync. Do you know why? Could you explain why? A promise is greedy, which basically means that it has to start immediately, right? If a promise constructor was asynchronous, then it would have to wait until the next turn so that the promise would start at all, right? So if it was an AJAX request, the request would be shot only after the current message has been done, right? So it has to be started immediately, right? So when we've got this code, let's take a look at this example. The output is going to be before. Now we're going to set timeout to register it here, right now. We're going to skip this function. We're going to display the console log after, right? Then this is the message. This is one full message. It's going to be finished. It's thrown away. And then within the next turn of the event loop, this function is going to be taken and executed. So what we can do with asynchronous functions is basically keeping in mind what is asynchronous. Just try to cut out it just in your imagination, right? And this is how you get which pieces are the messages, right? So this is one message, and the rest of this console log wrapper is just another message. It's going to be put on the message queue. A message queue is just a FIFO, first in, first out queue, that the messages will be taken from the first one, right? The next one, the next one. Event loop can do only one thing at a time, right? This is why JavaScript is a single-threaded. But obviously, to keep all these things running, it's not just one thread within one browser tab, right? Event loop has to be in another tab, thread. Web API like timer or AJAX or WebSockets has to be yet in another threads. The same for WebKit, right? This has to be done. This is a lot more complex than just saying that JavaScript is single-threaded. This is the thread. This is the single thread that we write code, and it's going to be executed here. But there are many more threads that keep the whole, let's say, model, the whole engine running. Right. And additionally, if we dive deeper into these code snippets, we would see that these structures are different, like they're not combined to each other. So let's take a look at this piece of code. Could you tell me what is going to be the output of this snippet? It's just console log 1, 2, 3, 4, 5. Just what is going to be the order? Go on, don't be shy. Yeah, exactly. It's going to be 1, 4, 5, 3, 2. And now let's examine what is going on here. So this is the immediately invoked function expression. As it says, it's immediately invoked, so it's going to be executed right now, immediately. So when JavaScript finds out this bracket, it's going to find the matching one. Now we're trying to invoke it, so it guesses that the expression that is inside the brackets is going to be a function. There are no arguments here, so there are no parameters here, and we're going to get inside this function immediately, synchronously. So we are just executing one. We are registering the timeout for this function. We're registering the timeout for another function, and at this moment, the timer is starting, right? It's in another thread. We're executing 4. Now we hit end of the function, so it's basically return undefined. We're getting here console log 5, right? And the first message is done. This is the first message, right? So that's the first thing. The run to completion says this is a rule that that defines this asynchronous model, that when one thing is started, it cannot, let's say, it has to finish before any other thing can be executed, right? So it's a queue of messages. It's just a queue of different code that can be executed one after another. So right now, the web API timer is counting which of these messages is going to be done as the first. It's not, these messages are not yet in the event queue. They're in the web API timer. And obviously, this one is going to be ready as the first one. It gets as the first message. Then after 1 second, only after 1 second, this one is going to be put onto the message queue. Hence, this is the second message, and that's the third message. Basically, this is how it's executed. So, having this in mind, let's go further. One of the most critical bugs that we can make, and actually there is no tool that could find it for us, is doing race conditions. Race conditions is when we do some assumptions on the order of asynchronous operations, whether one or another is going to finish as the first one, right? So we cannot make any assumptions. Another thing worth mentioning is that when we get just functions and try to nest them one inside another, this gets really messy and difficult to deal with. It's called callback hell, it's called flying V, pyramid of doom, there are different names for that, but basically this snippet taken from callbackhell.com demonstrates how difficult this can be to read the code. Obviously, it's not going to be run from the top to the bottom, right? There is going to be some part here, and some part here, and some part here. It's just going to be nested, right? It takes really long time to analyze this kind of let's say code base. So we need something better, and this is where we arrive into promises. So a promise is a representation of a single operation that will be finished in the future, but I know what to do when it completes right now, up front. I know what to do with it before it completes. I know how to deal with it. I know how to handle the error, right? So we're not going to talk about the basics because I assume we know it. Instead, we can concentrate on the limitations. So a promise represents only a single item. So if I wanted to represent multiple items, like multiple, let's say, AJAX calls or just multiple operations, right? I could wrap it in an object or in an array, but in the next step, like in the next item of the promise chain, in the next callback, I would have to unpack it, right? And this would be really, really nasty and not necessarily satisfying to carry on with that. Then a promise is one-time operation. So if the operation that the promise represents is finished, I cannot reuse it to repeat the thing. I would have to use another promise. I would have to create another promise. Then, a promise is greedy. There is basically no start button. When I create a promise, it's running immediately, right? So creating a promise means that it's already running. Next thing, a promise is not cancelable. If I wanted to cancel something, I just have no way to do it with promises. With callbacks, as with XHR object, I can. If something is represented as a promise, there is no way. I can chain it with the next step, and the next step will basically cut off the chain so that it just doesn't proceed further, but there is no way to cancel a promise at this point. Also, this is one of the mistakes that beginners make very frequently. Having a promise is not the same as having the value of the promise, right? If I have a promise, there is no way for me to get the value that the promise will resolve with. The only way to do it is to chain with the then, right? And then the callback of the then will get it in, right? So it will be executed in the next turn, right? It's going to be in the then callback function, right? But having a promise in the same, let's say, scope, I cannot access it. I can only access it inside the chain. And finally, a promise representing one step can be chained with another steps. The output of step n becomes the input of step n plus 1. The output of step n plus 1 becomes input of step n plus 2, right? So we are just pushing one value to the next step. And if I have a long promise chain, and if I want to access not only the previous value, the very previous value, but I want to access the value 2 steps before, or 3 steps before, or 4 steps before, what can I do? What I should do with promises is basically to chain promises, but this way I cannot do it, right? So I could nest promises inside, and this is the way to do it, but yet this is considered as an anti-pattern. This is not what we should do with promises, right? This is basically breaking the rules. So there is no gentle way to do that, right? So as we can see, promises are really nice, they're really useful, and they're really easy, but they come with pretty many limitations, right? All right, so let's take a look at this simple example. This async op1 is returning a promise. We're chaining it with async op2, then we're chaining it with async op3, and with async op4. The result of the operation of op1 becomes the input for async op2 callback. The output of async op2 is going to be the input of async op3, and this is how we're just pushing the value to the next step and changing them to the next step, changing it to the next step, and so on. So this is how we chain promises, and actually this is the sequential processing approach, right? So there is just one after another, after another, after another, right? We're just making sure that this has to finish until the next step can go on. We can wrap it with a function, making sure that this promise chain is going to be returned. What is going to be returned from this function is the last promise, right? So a promise is just, let's say, this is a promise. Promise.then is going to return another function, another promise, sorry. .then is going to return another promise, the third promise here. .then is going to return the fourth promise. So we are returning the last one from here. And we can wrap it with a function so that it becomes reusable, and we can basically use this kind of pipeline in many places in my application. If I want to do parallel processing, I just need to start multiple promises at the same time, and just the fact that I'm having multiple promises either in variables or in an array or in any kind of aggregate, it means having multiple promises already means that they're running in parallel, right? So I'll just be waiting until all of them are fulfilled, right? So this is what promise all is doing. Again, I can return promise all so that I can make this kind of code reusable in my application. Promise all is just one out of many aggregates. So let's try to find a real-life example of promise all. So basically, the predicate here is that all of these promises have to fulfill so that the entire result fulfills, the resulting promise fulfills. So please give me a real-life example of a promise all regarding your travels, your life, your I don't know, work, whatever you do. Users connecting to a web chat. If you could just come up with an example that does not, that has nothing to do with computing or computers. All right, all my friends have to be in my car so that we can start and go with a vacation. In this example, if any of your friends call you and say, "Oh, I'm sorry, I'm just not going to be there," then you don't go, right? Is that what you mean? If yes, then fine. Could you? We can assume that. Yeah, for the sake of this example. Could you come up with an example where these promises are just different things? Because here, this is friend 1 coming to your car, friend 2 coming to your car, and so on. Could you think of something like a situation? Sorry? Make tea. All right, so you need to have water and you need to have tea. All right, let it be. All right, if you don't have tea, then you don't do it. All right, so if I have all these promises pending, then I'm waiting for all of them to finish. If p.1 fulfills, then I'm still waiting because I need them all. If p2 fails, then I'm failing the whole promise because the predicate of all of these promises to fulfill is not possible anymore, right? So I'm failing it with this single reason here. Promise all is the most known aggregate, but it's just one out of many. So now let's consider promise race, which is also part of ES6 standard. So the predicate behind promise.race is that the first promise that settles will settle the whole resulting promise, whether it's resolving or rejecting. Now, could you come up with an example, a real-life example? It's not that easy. This one was obvious. Car race. All right. I have let's say, a motorbike race, and all the, let's say, motorcycles are racing, and at one point, an engine of one of the cycles is just broken. The driver just doesn't fall, there is nothing wrong happening to him, it just stops. And all the rest is keeping on racing. In this case, the first promise that has settled is the failing promise, and basically it fails the whole race. Is this the case? No. No. Actually, this is a mistake that like 99.9% JS developers make. Let's not focus only on the positive scenario. Let's concentrate also on the negative scenario, right? This is what you have built into the library, so this is most likely to be used by you, right? So if any of these promise fails as the first one, is going to fail the whole thing, right? So in this case, if one of the engines basically breaks, then it would make the whole promise race aggregate break. What you meant with this race is promise.any. The predicate here is that at least any of the promises has to fulfill so that the whole thing fulfills, right? So if p1 fails, then it still can happen. p2 fails, still can happen. p3 fails, still can happen. And now if p4 fails, then, at least one is not possible anymore, so that then we fail the whole thing with all the reasons, right? This does not, both this scenario and this scenario, they don't base on the time of the promise resolving, they just positional for us to be easier to determine. But if p1, 2, 3, and 4 are pending, and p3 is the first one to resolve, then the whole thing resolves with it, right? We're not waiting for the rest. That's pretty much logical, right? And finally, we have promise.sum. They're both implemented in Bluebird library, which is pretty easy to polyfill in our library, in our application, whether we use JavaScript or TypeScript or Flow, whatever. And promise.sum is a generalization over promise.any. In promise.any, at least one has to fulfill, and here at least n has to fulfill. In this example, we just have to. So this is what I wanted to say about promises. So a promise, just to sum up, is a representation of a single thing, right? So now let's get to generators. We get the yield keyword, which basically on the road in states says that now I have to give control to the other side of the road, right? Somebody else will take the control on the road. I have to stop. So let's take a look at these examples. Here I've got a function that returns an array, and here I've got a generator, note this asterisk here, that uses this new yield keyword. Basically, a traditional function can execute either until it returns gracefully, it was just executed in a positive way, and it returns a value, or it throws at some point. There is an error and it's interrupted, and it's going to interrupt the whole message, the whole piece that was put that was taken from the message queue and executed by the event loop. So it's either all or nothing here. But with generators, I can yield a value, and the generator suspends, right? It basically pauses, does nothing until it's asked to yield another value, right? So the generator can suspend on each of the yields, just pausing, and then the other side takes the control. When the other side requires the next item, it will basically ask for it, and the generator will resume executing the code until it reaches the next yield keyword, right? So basically, I can do the same things, but within arrays, I have to allocate the entire thing in the memory, right? So in this case, it's not a problem, but if I was doing Node.js processing and if I had, let's say, 3 millions, 5 millions of items, it would be pretty much memory consuming, right? So here, I just consume this one value that I need at a time, right? So it's a completely different approach. Basically, this one is greedy, so that it has to allocate the whole thing up front, even if not the whole thing is needed. And here, it's lazy. If you compare, if I wanted to map a collection of 5 million elements, it's going to be a lot more, let's say, memory consuming than if I was just mapping item by item, right? It's such a case. And as JavaScript is becoming more and more advanced language, the folks in TC39 has concluded in the iteration protocol. So this is basically a common point for many different structures, such as arrays, maps, sets, and the generators to be iterated. They're called iterables. So basically, an iterable is something that I can iterate over, right? Give me next thing, give me next thing, give me next thing, give me next thing, right? I can do it with arrays, but I can also do it with generators. I can also do it with sets, and whatever kind of data structure I write, and I just implement the iteration protocol. I can use it in the for-off loop that has been introduced in ES6, but I can also use it with the spread operator, with array from, and the generator delegation as well. So this is a, let's say, common concept between different data structures and between different syntax constructs. We're going to be interested in generators in terms of coroutines, which we'll see in an example in a while. So a generator is this function with the asterisk. We're going to call it here, and the generator is going to return an iterator, right? As you can see with this output on the right-hand side. When I execute the generator, I am not going into the function yet, right? It's lazy, so it's not going to, start yet. I'm logging console log 1 outside, then only when I call next, it's going to start, so it's as lazy as possible, right? It will do at the very last moment that it can. I'm calling the next, so at this next, it's going to start, do the console log 1 inside, yield the value A. This value A is going to be returned from here, reft with an object. Let's forget it for a while. Now the control has been moved from within the generator into the outer world, right? So I'm doing console log 2 outside. Now I'm calling iter.next. So I'm going back here, the place that the generator has suspended. It's going to execute the code. It's going to output the console log 2 inside, and it will pause on the next yield keyword, right? And suspending means that the outer world will gain the control back. So I'm outputting console log 3 here. Note that in this example, this generator is not finished yet, right? I didn't hit this ending bracket, neither the return keyword, right? So this is just suspended. One thing more to note in generators is that the generator can yield the value into the outside world, but also this guy calling iter.next, it can call it with one parameter, injecting a value into the generator, right? So there is two-way communication here. And also, not only we have next, but we can call throw, which basically injects an error into the generator. If you ask, like, why would I need it? Then I would say, like, I don't think you would necessarily need it, but there are many things, including coroutines and async await, that are built on top of that, right? So if I have called throw here, it means that the place that I would resume the generator, this is the place that the error would be thrown, right? Obviously, I could do try catch finally here, but let's just skip it for a while. So we have promises and we have generators, and we want to combine them to get a coroutine, right? So a generator is a coroutine is going to be a generator from the outside world, and it's going to start immediately. Although generators are lazy, a coroutine is going to start immediately because it's going to return a promise. A coroutine is going to be logically the same as a promise chain, right? But it's going to return the result of the promise chain, which is basically the last promise, right? So it's going to be greedy. It's going to start immediately, right? So there is no this initial next that has to start the generator. It will start immediately. Now, the whole thing is that we are going to yield promises. We're not going to yield just simple values. We're going to yield promises. When I yield a promise, I'm going to suspend on this promise, right? So basically, the generator will pause while yielding the promise. And the generator is just waiting for the promise to resolve, right? So it's the promise is pending, and the generator is paused, right? When the promise gets resolved or rejected, the generator is resumed, right? So we are using the fact that a promise can be either pending or resolved, rejected, and the generator can be suspended or resumed, right? And we're just matching these two things. And if I resolve, if the promise gets resolved, the generator is called with the next value. If the promise is rejected, the generator is going to have the throw thing injected, right? The error is going to inject it into the coroutine. Right, so the generator will resume when the promise is settled. So basically, there is a mechanism that I will yield on a promise, and I will put a then on this promise. The then callback will call next, right, on the generator. Then it will call then, it will call next, it will call then, it will call next. So there is a loop of this next, then, next, then. And also, when I yield the promise, right, I am going to then, on the value that has been yielded on the promise, a promise callback has a function that accepts one parameter, which is basically the value that the promise resolves with. This value is going to be put into the iter next, so that basically generator will get the value of the promise internally. So basically, I get the JSON from an AJAX request. We will see that just in an example in a while. The thing is, if I yield a promise, I don't get this mechanism yet, because if I yield a promise, then the outside world will basically get a promise, right? This is not what I want. So there has to be a small, tiny wrapper around. So let's just put this on the side. Writing, using coroutines is mainly about writing asynchronous code, because there are going to be multiple operations that we will be waiting for in a strictly synchronous manner. So we can forget all the things that we know about promises, that they have to be then'd, that they accept a function with one parameter, that we have to return it, then we can have access to the previous value only. We can forget about all these limitations when writing coroutines. So this is an example of a coroutine. We have this function asterisk sequential thing. This is going to be sequential processing. So this is the same as we've had with promise chain, right? So here I have var v1 equals yield async op. I'm yielding a promise. As long as this thing is pending, this generator is going to be suspended, right? When this promise settles, let's say when it fulfills, the generator is going to be resumed, and when this wrapper here that we have to think about when talking about coroutines, it will inject the value that it accepted from the then. So it basically, this is the JSON from Ajax, this is the value that the promise resolves. It's going to be returned here. So basically what the yield keyword is doing, it is taking the promise and it's pulling the value out of the promise, right? When we get back to promises, we have said that we cannot access the value from the promise in any other way rather than attaching the then callback, right? Here I can just forget about the promise API, right? This v1 is going to be the JSON resulting from an AJAX request. v2 is going to be the value resulting from another AJAX request, and so on and so on. And also, take a look at this snippet here. Here, I can return whatever expression I want. I can add some things here, I can form an object, I can do anything here, and I don't have to do promise.all on all the promises that I got here. Additionally, I have v1, v2, v3, and all other variables that I created on my road here. So I have pretty much access to everything, right? I don't have to split my code into distinct steps of the promise chain. I have everything at my hand, and this is just a function, right? I just need to understand that I should yield a promise. This is the place that the generator is going to pause, and I've got pretty much a JavaScript function, right? This is the beautiful simplicity behind coroutines. The only bad thing is that I have to remember to wrap this thing with the async wrapper. It's just a closure that is going to do this then next thing basically running. So this is sequential processing. I can wrap it with a function from the outside world. It doesn't matter if it's a coroutine or if it's a promise chain. It's just going to return a promise. I can make it reusable, wrapping with a function. Now, this is parallel processing. As we've said before, just the fact that I'm having multiple promises in my hands means that they are running in parallel, right? So instead of doing yield immediately here, which will pause the code here at this point, I can just postpone the yield to a point somewhere later in time, right? And I can yield it like just in an expression. Here, I might receive numbers or strings just to add them, right? But it doesn't necessarily, it's not important. I can use it to return it. I can use it to pass it as an argument to a function call. I can use it whatever way I want, right? I can also make it reusable by wrapping it with a function and calling the async wrapper here so that it becomes a coroutine, right? So this is the same as I would have with promise all, but with promises, I could not create a loop, or the loop would be very hacky. For instance, a real-life example I asked recently 1 week ago during a training. An example of a promise chain. I'm asking my boss for a raise, and I'm pending. When I get the raise, then immediately I ask again for the next raise, right? When I get it, then I ask for another one. The thing with promises is that I should know all the steps up front, right? So how many steps would I register up front? I don't know how many steps would be there, right? A promise chain represents a sequence of a definite number, of a deterministic number of steps, right? And here, I could just do a while loop, a for off loop, whatever kind of loop, right? I could just do a lot more complicated logic here, and this is just plain JavaScript, right? Just the yield keyword here, right? But just to make it easy, when you just yield a promise, this is going to pause at this point, and the yield keyword is going to pull out the value from a promise, and the result of yield p.1 is just going to be the value of the promise, right? That's all, pretty much all. So if you were wondering what is this async function here, so this is just a couple of lines of code that do the right thing. Here you can see the interesting point is that we have promise resolve just to make sure even if you don't yield a promise, this will be wrapped with a promise here. The result.value, this is the iteration protocol. Now, for the yielded promise, I'm going to attach then, I'm going to register the next step. This is the result of my promise, and I'm going to ask the generator to give me the next value. I'm going to inject the value into the generator so that I get this var v1, v2, not as a promise, but as a value of the promise, right? And I get it once the promise has resolved, right? As long as it's pending, it's not going to be executed. So this is the place that then next loop is just being run. So it's a beautiful logic, isn't it? Right. So you might be wondering, like, why do I have to bother about this async thing, right? Why do I have to remember to wrap it, right? We are in 2017, and one of these TC39 heroes has picked up the challenge to introduce async functions, which is basically async08. Async08 is pretty much everything that we have just said about coroutines, just we don't have to worry about this async wrapper. It's just built into the language, right? So coroutine is a generator, async08 is going to, and async function is also going to be a generator. This becomes part of the language. So it's already in the browser it's been for many months, and it has, I think it has landed in Node.js in one of the recent versions as well. So sequential processing here is exactly the same as we have seen in coroutines, just we don't have the asterisk here, but we have the async keyword instead. And instead of yield keyword, we have await, right? But what we should do is to await the promise, then the generator is going to suspend, the async function is going to suspend here. Once the promise gets resolved, await is going to pull out the value and is going to, this expression, await promise, is going to be evaluated to the value of the promise. If you wonder how to handle errors in this case, basically, if this promise is, if any of these awaited or yielded promises will fail, then this wrapper, async in this case, or async in case of coroutines, is going to inject error here. So it would basically have the same impact as if you had a throw here just an error. And if you have a throw within a callback of a promise, it will basically fail the whole promise. So if you don't, you could put a try-catch around any of these awaits, right? But instead, like if you want to handle one special error in a very special way, this is what you should do, wrap it with a try-catch. But if you don't care about different ways to handle errors for different promises, you can just leave it as it is here, right? And you could just do a catch here, a single catch. Because if you want to display an error, then you won't do it here, right? Because you don't know the page that you are at, right? But you would do it from this level, knowing which page you're in, right? So if you do a catch here, then it's going to catch all the errors from all the promises, right? Just as if you had with a promise chain. So this is how we do sequential processing. And for parallel processing, we have a similar code snippet that we had with coroutines. So we're starting all the promises. We're gathering them here in this example in different variables. The fact that I'm having multiple promises means that they're running in parallel. And I'm just postponing the await on a promise until the very last line, right? So in this case, when I have op1, op2, op3, and op4, as you can see, op3 takes the longest time to fulfill, right? This is going to be the last one. So what the interpreter will do is return await p1, so it's going to wait this amount of time. When this p1 fulfills, then it's going to evaluate the await p1 with the value that the promise has resolved with. It's going to plus await p2, then it's waiting on this promise, but it has already resolved, right? So it evaluates to the value of the promise. Now it goes to await p3. And as you can see, this is the one that will take the longest. So now it will wait for p3. Then after it resolves, it will evaluate with the value of the promise. And finally, await p4, which is available at that time, right? So this is pretty much all that we have with async await. Just to display, this is a popular animation that displays the difference between the callback, the nested callbacks, a promise chain, and async await. This is a demonstration, right? It's pretty easy to get the grasp of what is moving where. All right, an example of async await use case. So basically, I would like to have multiple steps that form a bigger thing, right? Let's do a transfer. So I have a list of transfers in my banking interface. When I click the new transfer, this is the moment that I'm executing the coroutine or the async function, right? Now I'm starting the thing. So the first thing that I'm waiting for is to shoot a request. I'm waiting for the server to respond with a new anonymous transfer session. So I am awaiting the transfer initialize call. Now I am awaiting the user to fill in the data and to click just to proceed. So now I'm awaiting the user interaction. That's the second await. Now I'm sending the data to the server, right? So I am awaiting the response for the second call, right? So that's the third await. Now I am awaiting for the user to confirm, yes, this is the transfer that he wants to do. So that's the fourth await. Now I'm shooting the next call to the server just to confirm that, yes, this is the transfer that this guy wants to make. So I am awaiting the third call. And finally, now all has been settled, but still I am awaiting for the user to confirm that he acknowledges that this transfer is going to take place, right? And as we've said, a promise chain is going to return a promise. The same way a coroutine or async await is going to return a promise. So now it's up to us what this whole process is going to return. Is it going to be a transfer ID? Is it going to be all the transfer details? Is it going to be void, null, undefined, whatever we design? The question is, what is going to be used afterwards? So I can use the whole process, the sequence of all these steps, to attach a next action to it. So I was in a list of transfers, so I can just attach the next step, which is going to be just reload the list of transfers, right? But this was on a different level. This was outside of the async await of the promise chain, right? So this is an example of a sequence of operations. Right. So this is just to sum up async await. This is a simplification, let's say a pseudocode written in TypeScript. So we've got a model that I'm going to begin the transfer with. So this method will return a promise that results with transfer ID. So this is the moment that I shoot a request that will initialize an empty transfer. Just HTTP post, whatever implementation I'm using. The second call is going to set the transfer details within that transfer session. So I'm telling which transfer to access. This is some kind of RESTful interface. And I'm setting the details here in some kind of HTTP post, whatever the implementation is. And I'm going to return a promise void. I don't care about what is being returned. The fact that I get 200 OK is just the confirmation that it succeeded. And finally, when all these details are set, I'm just going to confirm once the user has confirmed. I'm not talking about any kind of validation token, token things. So confirm transfer accepts transfer ID, just to make sure which transfer is going to be confirmed, right? And that's the thing. So just to sum up, this async function schedule transfer with the component. I just need to get a handler to the component when things are clicked, whether it's jQuery, React, Vue, whatever. So I'm awaiting the first initial AJAX request, right? This is that point. When this promise resolves, then I get this input, this view here. I'm waiting for the user to input the data here, so I'm waiting for the user to complete the step, and I'm waiting until he clicks, right? If he has written some data that is not valid, then I'm neither rejecting nor fulfilling the promise. I'm just waiting. When he or she clicks cancel, it's rejected. When everything is fine, it's okay. Otherwise, it's still pending. Or if he clicks outside, then I'm treating it as cancel, rejected. So I'm waiting for the user to complete it. Now it's completed. Now I'm waiting for the AJAX, for the second AJAX call, and I get the confirm view. Now I'm waiting for the user. As you can see in JavaScript, I am waiting, always waiting for something. I am awaiting, right? That's the beauty of the language. And it's all done within a single thread as well. Right. So I'm waiting for the user to submit it. Then I'm shooting the third request. I'm awaiting the third request. When it's here, I can display the last view. And yet again, I'm awaiting the user submission, the user to confirm. And finally, when I click OK, all this thing is going to return a promise. And now the question that I have asked just a while before is, what do I want this whole process to resolve with? It can be transfer ID, it can be transfer details, or whatever kind of logic I want. The question is, the thing that will use this promise outside, what details does it have to have, right? If I want to reload just the list of transfers, then I don't need anything. So I could just return here, right? Or don't return, I would have return undefined. So it's here I'm just returning transfer ID. This is just up to our design to decide. All right, so let's stop part 1 at this point, and within 2 months we'll get back to the rest. So we have discussed this part here with asynchronous model, promises, coroutines, generators, and async await. So see you in 2 months. Thank you. Right?
Hello. Oh, okay. Wait a second, Tomasz, because
Sure.
still we might have some questions for the first part, and obviously, well, I'm amazed. Always your presentations have so much meat. So I love it. Would you
Not
like
for
to ask
vegetarians.
some questions to this part? I'm sure you would, because for me, for example, well, this is a stupid, naive question, but. Possibly, part of us, or even a major part of us, can ask these questions. Why are we doing so much await and stuff like this. When we want to use asynchronous code, isn't it something like a step backwards? Does it have the same results like synchronous calls, synchronous coding as it was before? Is the effect the same? Isn't the effect the same?
I would answer in a slightly different way than I guess you might expect. Basically, if you say what we used to do is, you might be considering, let's say, I don't know, Ruby, PHP, Python, Java, or any kind of these server-side technologies. And once you're on a server, you have all the files here, right? You can do the logic that you have here, right? And when you are in a browser, in a client, right, you are waiting for the user to do something, so you have to wait for it. And you also need to access the resources that you don't have here, right? So you also have to wait for them, right? So there is basically no other way to do it. You might do multi-threaded processing, right? But then you would have to make sure that you don't do deadlocks. Or you might do JavaScript, right, with the event loop. You could also implement this pattern with reactor pattern in Python, Java, or whatever kind of technology, right? But here, if we're doing front-end things, we have to wait for something, right? So this is not just up to our design. This is something that you are, this is your destiny, right? To wait for things. If we do Node.js processing, then if we have things available on a disk, then we can, again, we have like read file, which is async by default. We have read file sync, which is blocking, right? So with Node.js, you can do pretty much many things, either in the default async manner, which will basically use the event loop, or you can block the process, right? So it's not up to you if something is available for you or not. If it's not available, then you can either make it async or just block. And in JavaScript, you have one thread, so blocking is not a good solution, basically.
Thanks. You didn't disappoint me with this answer. Thank you very much. So one last question, something like this. Okay, we're going to be short in time, so thank you very much, Tomek.
Thank you.
Great applause for you.